Most metals are extracted from ores found in the Earth's crust. The method used to extract a metal from its ore is linked to the reactivity of the metal. Part of the reactivity series is shown in figure 9. So you can see we've got a list of most reactive to least reactive. And I've inserted carbon here because carbon is used as an element which can help extract certain metals, providing it's more reactive than those metals. So carbon is more reactive than these, but less reactive than these. The method of extraction is called reduction by carbon or reduction with carbon. Iron ore contains iron oxide. Iron's over here. Iron is extracted from iron oxide by heating the oxide with carbon. In this reaction is carbon reduced, iron oxide is neutralized, iron oxide is reduced, iron is oxidized. Okay, so this is the reaction over here. We can see that we have iron oxide here plus carbon produces iron and carbon dioxide. Now what we're doing is we're taking the oxygen away from the iron oxide and it's bonding with carbon to leave you with iron and carbon dioxide. Now whenever you are reducing with carbon, it's an example of a reduction and oxidation reaction because oxygen is being lost and gained depending on the element or the compound you're looking at. So we know that reduction and oxidation is happening. That can be a multiple choice question as well. They might say, is this an example of reduction, oxidation, or both? And it's always both. The second thing, the other thing you might get tricked on, notice that carbon is being oxidized, it's gaining oxygen. But it's not iron that's being reduced, it's iron oxide that's being reduced. The oxygen is leaving its compound, which was iron oxide. So the only correct one, and this is the real catch here, if you see here, is between these two here. Because many people would favour this one when it's wrong. They want to go for iron oxide. It's a common thing they try and catch you up on. So remember, iron oxide is reduced, not iron. The formula for iron oxide is Fe2O3. Calculate the maximum mass of iron that can be obtained from 240 tons of iron oxide, Fe2O3. So in other words, if you have 240 tons of this, imagine in a perfect world, how much mass would be iron? Could you extract, if you could perfectly separate the iron from the oxygen, how much mass would you get? That's why it says maximum. Tons, don't let that phase you. Tons, it can be kilograms, grams, it doesn't matter. It's just a unit of mass. So 240 is what you're interested in. And it gives you the atomic mass of oxygen and iron. So how do you do this? It's quite easy. Firstly, you have to work out the formula mass of iron oxide. So what I mean by that is you have to add up the individual masses of the atoms that make up iron oxide. So there's 2 iron atoms, 56 plus 56, and 3 oxygen atoms, 16 plus 16 plus 16. And you get an MR, or formula mass, of 160. So we're just adding up the atomic masses, the relative atomic masses of the different elements in the compound. Then you have to work out the formula mass for iron, or the mass of iron in the compound. Now there's 2 lots of iron, so that's there. And the reason why we want iron is because that's what we're trying to work out, the mass of iron. Now this is going somewhere. So what we do now is we have to work out, okay, what percentage of iron is found in iron oxide? So what proportion of iron oxide is accounted for by iron as a percentage? So we do the bit we're interested in, 112, which is the mass of iron, divided by the formula mass of iron oxide, because that is the proportion of iron in the total, of the total, 160, and that's 70%. But the answer is, remember, you're trying to calculate the maximum mass, not a percentage. So what we're saying is 70% of that 240 tons will be accounted for by iron. In an ideal world, that's what we could extract. But obviously extraction techniques aren't perfect. But if they were, we'd get 70% of 240. Now to work out 70%, you decimalize the percentage, but you already had it here, 0.7. And you simply multiply it by the mass in question, which is 240, which would be 168 tons. I just added tons on at the end because it said tons there. Aluminium cannot be extracted by heating its oxide with carbon. Aluminium has to be extracted from its oxide by electrolysis. Explain why. Well, if we look here, aluminium is higher up in the reactivity series than carbon. In other words, it forms a very stable compound because it reacts using a lot of energy with, let's say, oxygen, and so it forms a very stable compound. So carbon will not be able to displace aluminium from its compound. It will not be able to form carbon dioxide because it's just less reactive. So you need something which is a far more energetic process, which is electrolysis. We need the energy and electricity to break aluminium down, to decompose it, to separate it from oxygen. So aluminium is more reactive than carbon. That's stating why we can't use carbon. Now we need to go into a little bit more detail. So aluminium oxide cannot be reduced by carbon. Remember, 2 marks for 2 points. Right. Predict the method that will have to be used to extract calcium from its ore. So if we look at calcium, calcium is also above carbon, so we'd have to use an energetic process like electrolysis. That's the only other option we have here. In recent years, research has been investigating alternative methods of extracting metals from soil. Researchers have found that growing certain plants in appropriate areas can result in phytoextraction of copper. Describe how growing plants can result in phytoextraction of copper. So you just need to learn about what phytoextraction is and record it here. You're just describing the process. Phytoextraction basically involves planting plants in copper rich, relatively copper rich soils, because we're running out of copper, but it does occur in trace elements in the ground. And plants will absorb copper ions from the soil. You must say ions, copper ions from the soil. And then it basically transports it to leaves, and you can burn the leaves, pluck the leaves and burn them to extract the copper. So then harvested and burned to leave the metal compound behind. Aluminium is extracted from its ore by electrolysis. Iron is extracted from its ore by heating with carbon. Both metals can be obtained by recycling. Explain the advantages of recycling aluminium and iron rather than extracting them from their ores. So you need to really talk about 2 things here. What's the disadvantage of extracting them from their ores, and what are the advantages that recycling brings? It's quite an easy one. You can access it using common sense, but there are a few finer points. So recycling conserves raw materials. Obviously that's the point of recycling. You don't have to keep on extracting things again and again. It requires less energy to melt and reform metals than extract them. So when you're trying to get them from their ore, let's say in quarries, it takes a lot of horsepower, it takes a lot of machinery, diggers and so on, and destroys landscape and so on, and a lot of fuels. You have to build transport to and from the quarry. Lots of issues with building a quarry and extracting things naturally, from the natural environment. So it requires much less energy just to get them from people put their recycling out, it gets collected, taken somewhere, melted down and reformed. Much less energy. So this will conserve fuel, and it produces less carbon dioxide, which is a greenhouse gas that contributes to global warming. So obviously recycling helps with the whole climate change issue, because as I said, you're not building new roads, you're not creating lots of pollution through destroying natural habitat with machinery, which require fuels as well, so you're saving there. It also reduces waste in landfill sites. If you're reusing things, you're not throwing them away, and that helps. And avoids the need to mine for ores, which links back to this extraction point. So you're not having to mine for ores again. So there's less damage to the environment. So these are all the advantages of recycling and the disadvantages, really, of extracting them from their ores. Just so you're aware, an ore is when it's a rock which contains the metal you want. So to extract it, you have to break and crush down the rock, and then you have to chemically treat, because the metal will be bonded to oxygen. So you have to use one of those extraction techniques like electrolysis or reduction with carbon to extract it as well, which is why it's polluting as well, because we saw that reduction with carbon produces carbon dioxide, and also electrolysis requires electricity, which also uses fossil fuels.